Okay, in logic, we have truth tables. Now, A and B will just be certain states, certain things that are either true or false. And we just want to discuss these simple truth tables. First off, this symbol means the complement of or the opposite of. So if A is true, the opposite of A would be false. If A is false, the opposite of A would be true. So if you see this tilde symbol, that just means the opposite of. Just of. Take the previous stuff and switch it. This is also the complement of. So if there's only true and false in the world, then what's outside of true would be false. So what's outside of true, the complement would be false, and what's outside of false, the complement would be true. So this is also the complement, similar as the complement in set theory. All right, next up, we have this symbol. This symbol is AND. It's equivalent to this symbol in sets theory. So, with AND, in order for an AND to be true, they both have to be true. So for A being true and B being true, they're both true, the AND would be true. If it's true and false, they're not both true, because this one's not true. They're not both true, so it's false. Since this one's not true, false. These are both not true, false. So for the AND, they both have to be true. So the AND is almost always false. The only time the AND in the truth tables is true is if they're both true to begin with. Now I already have the left side filled out. There's a nice way to fill that out, and I will demonstrate that on the next video. So the union, this is OR, it's like the union in set. So it's OR, it's one or the other or both. So either A or B have to be true. In this case, they're both true, that's fine. In this case, this one's true, great. In this case, this one's true, awesome. In this case, they're neither true. That's the one that's false. So with the OR, it just takes at least one true for the OR to be true. So what we see is the OR is almost always true. The only way an OR is false is if they're both false. Whereas with the AND, the only way the ANDs are true is if they're both true. Okay, so essentially with the ANDs, if you see a false, the answer is false. With the ORs, if you see a true, the answer is true. Okay, next up we have the if-then statements, the conditional statements. If A, then B. Now these statements are like innocent until proven guilty. So they are true until proven false. So you can assume that these are true and then see if any of them are wrong. Now, what you could see, so true implies true, that's correct. True implies false, that's the one. If A is true, and if A gives B, then B should have been true. So this one is wrong. That one is false. B didn't follow from A. If A is true, B should be true. Now, these other two, if A isn't true, B doesn't follow from it at all. B can be anything it wants. So these are true implies true. Or a false implies whatever you want. So what you look for on these are a true and a false gives a false. So you assume they're true, and the only one that messes that up is if you get a true-false pattern. Then that one's false. That one takes a bit more time, but the assumption of true until proven false, start with them all true, and then look for any pattern of a true-false pattern, and then that one change it to false. Okay, with the A, if and only if B, that means A follows from B and B follows from A. And so again, you can assume that they're all true, but since the arrow's going both ways, now you look for a true to false or a false to true, giving you false. So this one's bad and this one's bad. So those two would be replaced with false. We've proven those false. A true did not imply. Hold on. Am I doing that? No, I'm doing that wrong. I could just have the arrows wrong. A true should give you a true. It didn't work there. Here, a true should give you a true. Didn't work there. So you, again, assume that they're true unless you have a true going to a false in the arrows, in the conditions. A implies B. True can imply a false. Okay, so said one more time. With the conditionals, you can assume they're all true unless you can find a true arrow to false. Then you switch it to false because that didn't follow the condition. Okay. I hope this helps.